Okay, so in this video I'm going to have a look at the Leaving Cert Higher Level Maths Paper 2 for 2017. This is question 8. So in a particular country in 2015, the weights of 15-year-olds were normally distributed with a mean of 63.5 kilograms and a standard deviation of 10. So our population mean mu is 63.5 kilograms and standard deviation is 10 kilograms. Now in 2015, Mariska was a 15-year-old in that country. Her weight was 50 kilograms. So that's the X value here, 50 kilograms. Find the percentage of 15-year-olds in that country who weighed more than Mariska. So what we're going to do here is find the probability of picking someone at random who is more than 50 kilograms. We're going to convert that into a percentage, and that will be our answer. So in order to do that, we've got to find a Z value. So what I'm going to do first is just write down what we're asked. We're asked to find really the probability that X is going to be greater than 50 kilograms. Now we can't look this up in our tables. We've got to look up Z values. So we've got to find the probability that Z is greater than some value. So how do we do that? Well, our Z value is just going to be X minus mu. So how far is this X value from the mean? And then see how many standard deviations that is. So we've got to divide by sigma. So we're going to look at 50 minus 63.5, divide all that by 10. That will give us P, probability of Z, being greater than minus 1.35. Now, if you take your standard normal curve like this, you've got your mean here, your standardized mean here is 0, and we're looking at a Z value of minus 1.35. So minus 1.35, let's say, is here somewhere, minus 1.35. Now we're looking for the probability that Z is greater than minus 1.35, in other words, up here somewhere. Okay, so two things here that we can't do in our tables. We can't look up values that are greater than, and we can't look up negative values. So I'm going to have to flip this around, put the 1.35, minus 1.35 up here, and what do we actually get if we do that? We get our standard normal curve again, but this time we'll put the 0 here, and let's take 1.35 on this side, 1.35. Now if I look at this area down here, this area down here is exactly the same as this area up here because our normal curves are symmetrical. So if I look up this value, which I can do, first of all it's positive, and second of all I'm looking at less than 1.35, so I can actually do that. The probability of appearing down in this part of the graph is exactly the same as the probability of appearing in this part of the graph here. So it's the same thing. So really what I'm going to do is look up the probability that Z is less than 1.35, and when you do that you get, well, we'll do that here. I have the table here, so it's 1.35 we've got to look up. So this is our table here, and we're going to look up 1.3, and then we've got to go over to 5 here, so 5 is actually here. So if we go down to 1.35, we get 0.9115, 0.9115. So let's put that in, 0.9115. So that's the probability of picking someone at random and their weight will be greater than 50 kilograms. In other words, it'll appear up here. So as a percentage, we were asked to write this as a percentage, so our answer then as a percentage then will be 91.15%. So 91.15% of the 15-year-olds in this country will be heavier than 50 kilograms. Okay, so that's the first part of this question. Next part then is part 2 here. So in 2015, Kamal was a 15-year-old in that country. 1.5% of 15-year-olds in that country were heavier than Kamal. Find Kamal's weight. So this is very similar to this question here, except that in this case, in part 2 here, we were given the percentage and we're asked to work backwards to find the weight. So it's a working backwards kind of question. So we've got to find the z value, then find the x value. So let's have a look at doing that. Now, let's just have a look at our normal curve here, standard normal curve again, and we're looking for 15-year-olds. 1.5% of 15-year-olds in that country were heavier than Kamal. So we're talking about 1.5% to the right of Kamal's weight. So we're looking at somewhere maybe here. So this is about 1.5% of the population, let's say up here. 1.5% of the 15-year-olds would be in that area there, to the right of Kamal's weight on the graph. Now, this value here then, this z value we don't know. We're going to work that out. We'll call it z1, let's say. This z value here. And then we're going to use that to find his weight. So let's write down how we're going to start this. We're going to write down the probability of z being greater than z1 is equal to, we have the probability. Remember, this percentage here is really just 0.015 as a probability. So the probability of appearing in this part of the graph here would be 0.015. So that's going to be 0.015 here. Now all we've got to do then is, again, look, we've got a greater than sign here, so we can't really do that. So what I'm going to do is look at less than z1. So the probability of being greater than z1 is going to be 1 minus the probability of being less than z1. So it's going to be 1 minus 0.015, and that's just 0.985. If you think about it, 1.5% of the 15-year-olds would be in this region of the graph, so therefore 98.5% of the 15-year-olds would be in this part of the graph down here. So the probability of z being less than this particular value, z1 here, would be 0.985. Okay, so now all we've got to do is look up. We've got to work backwards to find. We have less than and we have a z1. We know that z1 is positive, so everything is fine here. So we've got to look up this 0.985 in our tables. So let's have a look for that. So just go back to this table again. Now we're looking for 0.985. So that's going to be somewhere around here. Yeah, this is it here, 0.985. It's an exact value here, so that's fine. So if we look over to find our z value is 2.1 anyway on this side, and it's going to be, if we go up here, it's actually going to be 0.7. So it's 2.17. So there's our 0.985 here. So it's 2.17 would be our z value. Let's go back here, 2.17. Okay, so we have our z value here. So this z here is 2.17. Now how do we work back to find our x value, our actual weight then? Well, we know that z is just x minus mu over sigma. We have our z value, it's 2.17. We don't know what x is, that's what we want to find out. We know our weight here is 63.5, and then we're dividing by 10. Okay, so just cross multiply here, you get 21.7 is equal to x minus 63.5, and that will just give me an x value here, an actual weight here of 85.2 kilograms. So this would be Kamal's actual weight. Okay, so let's do the next part of the question, which is part 3 here. This is an hypothesis test type question. So let's have a look. In 2016, 150 of the 15-year-olds in that country were randomly selected and their weights recorded. It was found that their weights were normally distributed with a mean weight of 62 kilograms and a standard deviation of 10 kilograms. So just to write that bit of information down, we know that our sample size was 150. The mean weight, so the X bar this time, not mu. Mu is the population mean, X bar here is the sample mean, and that's 62 kilograms. And then we have sigma of our X bars here. It's the same as a population standard deviation of 10 kilograms. Okay, test the hypothesis at a 5% level of significance that the mean weight of 15-year-olds in that country had not changed from 2015 to 2016. State the null hypothesis and your alternative hypothesis. Give your conclusion in the context of the question. That last sentence is very important. We'll have a look at that when we get this finished. So we've got to state our null hypothesis, which is H0. So that just is whatever is the status quo, whatever is considered the norm. And the norm here is that mu is 63.5 kilograms. In other words, the mean weight of 15-year-olds in that country, the mean weights of 15-year-olds in that country has not changed. From 2015 to 2016. And then our alternative hypothesis is just really the opposite of that. Mu is not equal to 63.5 kilograms. In other words, the mean, I won't write it all out again, but the mean weight has changed. Okay, so we've got to test this to a 5% level of significance. So what I'm going to do here is find a test statistic Z, or test statistic. So now, because we've taken a sample this time, our Z value is going to be our X bar minus mu over, this time we're not going to use sigma, we're going to, because we've a sample here, our standard deviation of our sample is called a standard error, and that's just sigma over square root of n. So if we work that out, we've got X bar, which is 62 kilograms, minus our mu here, which is 63.5. Then we're going to divide that by sigma, which is 10, over the square root of the sample size, which is 150. Okay, so if you work all that out, you get minus 1.837. So this is our Z value. Now, if you look at that Z value here, again, if we look at our standard normal curve here, we have minus 1.96, and we've got plus 1.96 here. So if you take that region there and that region there, they're called the critical regions. In other words, if our test statistic, if our Z value appeared in these regions here, then we would be rejecting the null hypothesis. But we can see here that our test statistic, our Z value here, is actually somewhere around here, minus 1.837. So it's not in the critical region, therefore we're going to fail to reject the null hypothesis. So just to write that out, to actually answer the question that we're asked, so we would say something like, since minus 1.837 is greater than minus 1.96, so it's on the right hand side of 1.96, it's not in the critical region, it is not in the critical region. So therefore, we fail to reject null hypothesis. So we're going to fail to reject a null hypothesis. Now this is part of the answer, but it also said that we need to give our answer in the context of the actual story itself. So what we're going to do here is say, and we conclude that the mean weight of 15-year-olds in that country has not changed from 2015 to 2016. Okay, so that's it. As I say, you must give you must not only say that you're rejecting or failing to reject the null hypothesis, but you must also give your answer in terms of the actual in the context rather of the actual story itself. Okay, so let's move on to the next part of this question. This is to do with a probability and a tree diagram. We're given a tree diagram down here, and we've got to fill in various probabilities and answer questions on it. So let's have a look at that. So in Galway, rain falls in the morning on 1/3 of the school days in the year. So actually what I'm going to do here is going to read each line. I know what I've got to do here, so what I'm going to do is read each line and fill in the probabilities as we go along. So we're given all this information here, and we're asked to write the probability associated with each branch of the tree diagram and the probability of each outcome into the blank boxes below are provided. So in other words, we have this tree diagram here, and you can see all these branches here with blank probabilities, and then we've got our outcomes at the end here. We've got to calculate those as well. So let's work through those. So the first sentence here says that in Galway, rain falls in the morning on 1/3 of school days in the year. So they filled that out here. So this is rain here, this is not raining here. So it's going to rain on 1/3 of the school days. So if that's the case, then this must be 2/3 here. Okay, next sentence then just says, when it is raining, the probability of heavy traffic is 1/2. So when it is raining, so we've got to go up here, the probability that we get heavy traffic is 1/2. So the probability that we don't get heavy traffic then must also be 1/2. Next sentence then just says, when it is not raining, the probability of heavy traffic is 1/4. So when it is not raining, the probability of heavy traffic, which is here, is 1/4. So the probability of no traffic then must be 3/4. Okay, so this is where we were. Next line then, when it is raining and there is heavy traffic, the probability of being late for school is 1/2. So when it is raining and there is heavy traffic, the probability of being late for school is 1/2. So down this branch here then, the probability of not being late must also be 1/2. Okay, almost there. Let's see. When it is not raining and there is no heavy traffic, the probability of being late for school is 1/8. So when it is not raining, there is no heavy traffic, the probability of being late for school is 1/2. Or sorry, it's not 1/2, it's 1/8, I should say. So the probability of not being late then must be 7/8. Okay, next one. So we've done this line here. So the next one is, in any other situation, the probability of being late for school is 1/5. So in any other situation, the probability of being late for school is 1/5. And they filled one of these out already. So this is one of our late. So if this is 1/5, this branch here must be 4/5. And we have another 2 branches here. So this is another late. So this is another situation, if you like. So this must be 1/5 here, as we're told in the question. So this must be 4/5 down here. So that's all of these probabilities filled in The next thing we've got to do is look at filling out these outcome probabilities here. The way you do that is you just got to multiply out each set of branches. So in other words, if it is raining and there's heavy traffic and you're late, that means you got to multiply 1/3 by 1/2 by 1/2 here, and you get 1/12 here. So when you say something and something and something, the and there just means you multiply each probability. So if we go up along here and down along here, it's actually the same set of figures, so it's also 1/12. If we go up along here, raining, no traffic and late here, then we get 1/30. If we come up along here, down along here, down along here, not being late, then it's 2/15. If we come down, up and up here, we get 1/30. If we come down, up and down here, we get, that was 1/30, so this is 2/15. Next one then, here, this is 1/16, and the last one is 7/16. Okay, so that's all our outcome probabilities filled out. Now, if you want to just check that your numbers are correct, what you could do, you got to remember that probability should add up to 1. So all of these probabilities down along the right hand side here should add up to 1, and you'll find that they do when you actually when you add them up. You will get 1 here if you add them up. So let's move on to the next part of the question. It says, on a random school day in Galway, find the probability of being late for school. So you can see that you can be late here, or here, or here, or here. So in other words, these situations can happen, or these situations here can happen, or these situations can happen, or these situations here can happen. So there are 4 possibilities here. So it's this, or this, or this, or this. So when you use the word or, you're adding probabilities. So you've got to add these probabilities on the right hand side. So in other words, the probability of being late for school on a random school day is just going to be equal to 1/12 plus 1/30, 1/30th plus 1/30th plus 1/16. And when you add those, you actually get 17/80. So this is our answer here. Okay, next one, the last one actually, it says, on a random school day in Galway, find the probability that it is raining in the morning given that you were late for school. So this is actually a conditional probability type question. So we want the probability that it is raining. That's what we're asked for. Find the probability that it is raining given that we were late for school. So using our conditional probability equation, that's just going to be the probability of or intersection L over the probability of L. So you've got to work out the top line. We know the bottom line, we've worked it out up here already. So the top line then is the probability of raining and being late. The probability of raining and being late. So let's have a look at our diagram again. Well, this is raining up here, and there are 2 possibilities of being late when it's raining. We can go up along here, we can go up along here. So it's this and this. Remember, intersection means and multiplying, or sorry, no, we've got to do intersection here. So it's going to be this, we can go up along this branch here, sorry, excuse me, we can go up along this branch here, or we can go down along this branch here. So it's the intersection of these 2 here. So what we've got to do here is we can it can be raining, there can be heavy traffic, and we can be late, or it can be raining, there can be no traffic, and we can be late. So it's these 2 here that we've actually got to add. So it's 1/12 plus 1/30. Because there are two possibilities, so we can go down this branch or we can go down this branch here. So we've got to add these two here, and the probability of being late then is just 17/80, which was on the bottom here. Okay, so let's just work this out. So on the top line, you'll get 7/60. On the bottom line, we've got 17/80. So if we're just dividing a fraction by a fraction, so you flip and multiply. So you flip the bottom one and multiply, and you end up with 28/51. Okay, so that's it for question 8.